Hi, I'm Ellie Pinchers, an Education Officer at the Royal Meteorological Society. In this series of short films, we're going to be covering some of the background information that teachers may find useful if they're teaching weather and climate at secondary level, and specifically if they're using our Weather and Climate Teaching Guide with accompanying classroom resources which can be found on our website MetLink, with links in the text below. In this film, I'll be looking at anticyclones, otherwise known as high pressure systems. A high pressure system, also known as an anticyclone, occurs when the weather is dominated by stable conditions. In an anticyclone, air is descending, may be linked to the large-scale pattern of ascent and descent associated with the global atmospheric circulation, or because of more localised patterns of ascent and descent. As shown in the diagram here, when air is sinking, more air is drawn in at the top of the troposphere to take its place, and the sinking air diverges at the surface. The diverging air is slowed down by friction, but the air converging at the top isn't, so the total amount of air in the area accumulates. As surface pressure is a measure of how much air is above the ground, the surface pressure rises. As air sinks down from higher in the atmosphere, the mass of the air above it increases, and so the pressure increases. As a result, sinking air gets warmer. The rate of evaporation, which is linked to temperature, increases and cloud droplets evaporate, so the sky is usually clear. In winter, the clear, settled conditions and light winds associated with anticyclones can lead to frost. The clear sky allows the heat to be lost from the surface of the earth by radiation, allowing temperatures to fall steadily overnight, leading to air or ground frosts. In March 2013, persistent high pressure led to cold temperatures which caused particular problems for hill sheep farmers, with sheep lambing into snow. In summer, the clear settled conditions associated with anticyclones can bring long sunny days and warm temperatures. The weather is normally dry, although occasionally localised patches of very hot ground temperature can trigger thunderstorms. An anticyclone situated over the UK or near continent usually brings warm, fine weather. Sometimes in the winter or early spring, the ground can cool considerably overnight and in turn can cool the air in contact with the ground to the point where cloud forms, fog or low cloud. Because of the light winds associated with anticyclones, this fog stays put. The sun is not warm enough in the day to evaporate the fog, and it can last for an extended period of time, and this is known as anticyclonic gloom. It is associated with an unusual temperature pattern. The air is colder closer to the ground than higher up. This reversal of the usual fall in temperature with height above the ground is called a temperature inversion, and it acts as a sort of atmospheric lid, trapping pollution, cloud and mist in the cool layer of air near the ground. Such weather may last for several days until the high pressure system collapses or until a freak frontal trough introduces cleaner air from outside the anticyclonic circulation. When anticyclones are over the sea, the weather can vary from fine and sunny to overcast cloud. This cloud may be thick enough to give drizzle and may fall low enough to produce fog. This happens most often during spring and is least frequent in autumn. If the anticyclone extends over both land and sea, cloud and fog can spread across coastal regions, sometimes reaching quite far inland. In the northern hemisphere, winds blow in a clockwise direction around the anticyclone, which we looked at in Chapter 8, the pressure and wind video. Isobars are normally widely spaced around an anticyclone and the winds are often quite weak. Anticyclones can be identified on weather charts as large areas of widely spaced isobars where pressure is higher than the surrounding areas. Anticyclones are usually much larger than depressions and tend to last longer. It's also worth pointing out that there is no critical threshold for high pressure. You can't say that anything, say, over 1,000 millibars is high pressure and anything lower is low pressure. Whether something is high or low simply depends on what surrounds it. If the pressure in one place is higher than the pressure all around, then it's a high. As our pressure values in general tend to be higher in the summer than in the winter, then a winter high might have a maximum value that's under 1,000 hectopascals, and a summer low might have a minimum pressure that's over 1,000 hectopascals. Sometimes an anticyclone doesn't move and remains stationary over the UK or nearby for a long period of time. These blocking highs divert much smaller depressions away to the north and lead to longer periods of clear weather. During the summer, these blocking anticyclones can lead to drought conditions as rain-bearing fronts are diverted around the country. This is what happened in 2018 when an anticyclone sat over the UK for much of the summer, causing a noticeable drop in rainfall and leading to fires such as the one on Saddleworth Moor, which blazed for more than 3 weeks, due to the hot and dry weather conditions. At its peak, the fire covered an area of 7 square miles and 100 soldiers were drafted in to help firefighters. For the weather to constitute a heat wave, it has to be unusually hot for a sustained period of time. So when do we get a heat wave in the UK? Well, tropical continental air can bring warm, sunny weather, but it's anticyclones or high pressure systems that give us the heat waves. As anticyclones tend to last a relatively long time, maybe several weeks, the ground and therefore the air above it can really heat up. Without any clouds, there's very little chance of rainfall. A UK heat wave is defined by the Met Office as a period of at least 3 days when the temperature is higher than the regional temperature threshold. If summer temperatures are usually quite high in a place, it has to get even hotter to count as a heat wave. So if you are based in a region in the south of the UK, the average summer temperature where you live is higher than the Scottish Highlands, and the threshold for heat waves is higher too. In India, a heat wave is declared when the temperature of a weather station reaches at least 30 degrees Celsius in a hilly area, or at least 40 degrees Celsius in a low-lying plain. This map shows the heat wave threshold in the UK. You'll see that there are regional differences. The threshold is 28 degrees Celsius around London, but only 25 degrees Celsius for Scotland, much of Wales, Northern England and the South West. As the climate warms, all weather types can still occur. But extremely cold weather happens less frequently and extremely warm weather happens more frequently. Weather that was unusually warm before becomes normal or more likely. All the 10 hottest UK temperatures ever recorded have happened in the years since 2003. So the Met Office has had to change its definition of what counts as a heat wave. Remember, it is a heat wave if the temperature is warmer than the normal for that place. So if the normal changes, then so does the definition of a heat wave. This map shows the heatwave threshold from 1961 to 1990 with the same colour key as the previous map. You'll notice it's quite different. The hot weather that we experience during a heatwave can lead to serious health issues for people, plants and animals. It's heat stroke that poses a risk to health during a heatwave. Normally we sweat to keep cool. During especially hot weather, our bodies may not be able to keep cool enough by sweating. This means our body temperature rises, which can lead to headaches, dizziness, and in some extreme cases, even death. Dehydration is another risk of heat waves. It can cause problems with breathing or heart rate. People who are elderly and already ill are especially vulnerable. It is actually the temperature at night that has the biggest impact on our health. If we can't cool down overnight, you're more likely to become ill. Heat waves are usually associated with lower levels of rainfall. Very dry conditions means that moorland and forest fires are more likely to break out. People are more likely to be outside, maybe having barbecues during hot weather, which can lead to sparks setting off dry grass and vegetation alight. Many vulnerable areas now ban things like barbecues, but cigarettes and cars can still pose risks. In 2022, the UK experienced 3 short heat waves. In mid-July, some parts of the UK saw temperatures reach over 40 degrees Celsius for the first time in recorded history. The highest temperature recorded was 40.3 degrees Celsius in Coningsby in Lincolnshire. This is 1.6 degrees Celsius above the previous highest recorded temperature for the UK, a record set in 2019. Scotland also had its highest temperature with 34.8 degrees Celsius recorded at Chatterhall. This weather chart is for the 17th of July during the heat wave. You'll see the large area of high pressure over the south of England. There is a depression or a storm to the north of Scotland, but that wouldn't affect most of the country. The high pressure will give clear skies and very light southerly winds as the air blows clockwise around the centre of the high. Temperatures were between 2 and 4 degrees Celsius warmer than they would have been without global warming. In other words, the event would have been impossible in a pre-industrial climate. The Met Office issues extreme heat warnings as part of the weather forecast so that people could be prepared to take precautions and keep an eye out for vulnerable people. A red warning was issued well in advance of the July heatwave, which was then declared a national emergency to allow various safety measures to be put in place. With these temperatures, illness and death can occur among the fit and healthy, not just the high-risk groups. On this map, which shows the area affected by heat warning, you can see the impact the sea has. Remember, water heats up and cools down more slowly than the land, so in hot periods the air nearer water tends to be cooler. And you can also see the effect of hills. The Pennines kept the area between Manchester and York cooler. Rail travel was suspended and some roads and airports closed as the tarmac melted. A number of schools announced that they would either close or allow pupils to wear PE kit instead of school uniform. Some places had to stop selling chocolate because it was melting on the shelves and in delivery vehicles. England experienced its driest July since 1935, and in the southeast and central southern England it was the driest July since records began in 1836. There were almost 25,000 wildfires across the country, and houses were destroyed in places including Nottinghamshire, Kent, Norfolk and South Yorkshire. The London Fire Brigade has its busiest day since World War II. There were impacts for water supply, with some regions announcing hose-pack bans. As well as the lack of rainfall, people tend to use more water during heat waves to water gardens and to fill paddling pools. There are also implications for electricity use, with more people running fans and air conditioning. Air conditioning is actually quite a tricky issue. It might cool the air inside the building, but it warms up the air outside, making the local problem even worse. Also, air conditioning units use hydrofluorocarbons, which are a really potent greenhouse gas. In England and Wales, around 3,000 deaths can be attributed to the 2022 heatwave. By 2100, the UK could see 40 degrees every 3 to 4 years unless we as a global community take very rapid action to limit the amount of greenhouse gases in the atmosphere. In urban areas, nature-based solutions such as planting trees, as well as creating water features and changing the colours and materials used in urban infrastructure, can really reduce the impact of heat waves. Earth.Null School is a great place to go and view current anticyclones around the world, linking them with global atmospheric circulation. In the next film, we're going to look at depressions, or low pressure systems.